All right, in this video, we are going to walk through finding the 6 trigonometric functions of an angle using a right triangle. So it says, given the triangle below, find the value of the 6 trigonometric functions for the angle A. All right, so the angle A is up here. All right, and now looking at our triangle, here we can see that for the angle A, right, this is the hypotenuse, right, because it's the side opposite the right angle. And then of the two legs, for the angle A, this is the one that's forming one side of the angle, right? So for the angle A, this would be the adjacent side. All right, and then the leg that does not form part of the angle A, right, is over here. So that would be the opposite side for A. Okay. And now the hypotenuse is the one thing that we do not have here. We don't know what the length of the hypotenuse is, right? And so we are going to have to calculate that with the Pythagorean theorem, right? The Pythagorean theorem says that if you have a right triangle, and the hypotenuse is c, then c squared is equal to a squared plus b squared. All right, the hypotenuse, the only thing that you really have to remember here is that the hypotenuse has to be c. Okay, a and b are the legs. It doesn't really matter what order you do those things in, right? So I'm going to put 4 for A, and B is 10. Again, it doesn't really matter if you did 10 squared plus 4 squared, right? That's fine. It's going to work out to be the same. The main thing you don't want to mess up is that C has to be the hypotenuse, and that's actually what we're looking for in here. All right, so we need to work this out. So 4 squared is 16. 10 squared is 100. So I get c squared equals 116. All right, and so c would be equal to plus or minus the square root of 116. And here I put the plus or minus right on here because there are 2 solutions to this equation. And forgetting that there are 2 solutions will cause problems, right, in this class and any other math class you're going to take after this, okay, for the most part. So I always put this plus or minus square root 116 in here. But since we're talking about the length of a triangle here, then it's going to be the positive one in here. All right, so square root 116. And now we need to simplify that a little bit. Let's see. So we're looking for a perfect square that will go into 116. And 4 will go into that 29 times. I think that's right. Yeah. All right. So that is 4 times 29. And so that would be the square root of 4, square root 29. So simplified, that comes out to be 2 square roots of 29. All right, so now we have all the sides of our triangle. So if you're missing one side, then you're going to have to use the Pythagorean theorem to find it. If you know 2 sides, right, you can figure out what the third side is. All right, and so now we are ready to start calculating the 6 trigonometric function, the value of the 6 trigonometric functions for the angle A. All right, so for the cosine, right, that's going to be adjacent over the hypotenuse. So the adjacent side is 4. The hypotenuse is 2 square roots 29. And we're going to simplify that. We have a common factor of 2 between the top and the bottom, right? So 2 goes into itself once, it goes into 4 2 times. So that's 2 over square root 29. And then rationalizing that, you would multiply top and bottom by the square root of 29. So you get 2 square roots of 29 over 29. Right, square root 29 times square root 29 would be the square root of 29 squared, which just comes out to be 29. All right, next one is sine. And sine is opposite over hypotenuse. The opposite for angle A is 10. The hypotenuse is 2 square root of 29. I have a common factor of 2 between the top and the bottom, right? So 2 goes into 2 once, it goes into 10 5 times. So I get 5 over square root 29. And then again, I don't want to leave a radical in the bottom part of this fraction, so I am going to multiply top and bottom by square root 29. So I get 5 square roots of 29 over 29 when I do that. All right, tangent. Is opposite over adjacent. So the opposite is 10. Adjacent is 4. And again, we have a common factor of 2. So 2 goes into 4 2 times. It goes into 10 5 times. So this comes out to be 5 halves. Next up is secant. All right, that is hypotenuse over adjacent. So the hypotenuse, the length of the hypotenuse is 2 square roots of 29. The length of the adjacent side is 4. Right? And here we have, again, a common factor of 2. 2 goes into itself once, it goes into 4 2 times. So I have square root of 29 over 2 for the secant. All right, next up is cosecant. That's going to be the hypotenuse over the opposite. And the hypotenuse is 2 square roots of 29. The opposite is 10. All right, and here we can, again, we have a common factor of 2 that's common to the numerator and denominator. So 2 goes into itself once, it goes into 10 5 times. So we wind up with square root of 29 over 5. And finally the cotangent. All right, the cotangent is going to be the adjacent over the opposite. So adjacent is 4 and the opposite is 10. And once again, the common factor of 2. 2 goes into 4 twice. It goes into 10 5 times. So that's going to come out to be 2/5. All right, and that is it for that one.